All right, in the last video, we started talking about how to calculate subatomic particles and a little bit about isotope notation. We pick up with this video talking about ions. So recall, the subatomic particles that have charges are the protons and the electrons. And even though they have specific charges, relatively, protons are +1 and electrons are -1. Ions are going to be atoms that have charges, and so we refer to them as ions instead of atoms, because atoms implies that they are neutral. So ions have charges, which means that they have a different number of electrons, because remember, protons is what dictates what element you're looking at. So if an element has a specific charge, it's because the number of electrons has changed. More specifically, we can give positive ions the name cation, and negative ions are called anions. A good way to remember that is if you look at the word cation, the letter T kind of looks like a plus sign. And if you look at anion has an extra N in there, and N stands for negative. So that's a way you can think about that. Now, in terms of figuring out how many electrons that a particular ion might have, let's take a look at an example. Suppose that you have the element oxygen. What is oxygen's atomic number? If you look at the periodic table, oxygen has an atomic number of 8, meaning it has 8 protons. If this oxygen atom was neutral, that means it would have 8 electrons because every positive needs to have a negative to cancel it out. But what if we were looking at not oxygen neutral, but oxygen that had a -2 charge? Does that mean that you now have 6 protons? No, you never change the protons, because if you had 6 protons, now that's carbon. So we don't want to change the number of protons. Instead, we want to change the number of electrons. Think about it. If it had overall a -2 charge, that means you must have 2 extra electrons, 2 extra negative particles that don't have any positive to cancel it out. And so really what that means is you have 10 electrons. A helpful equation you can use if you need to is the number of protons minus the charge will help you calculate the number of electrons. So in our oxygen example, if we were looking at 8 protons minus a -2, that's how we can get 10 electrons. Either way, whatever makes sense for you. So in summary, let's talk about what we've learned about our 3 subatomic particles with regards to how to calculate how many there are. For protons is equal to the atomic number, and the number of protons identifies the element. To calculate neutrons, take your mass number and minus your number of protons. Remember, if your number of protons is different than what would normally be on the periodic table, that's how you know you have an isotope. And to calculate electrons, we can use the equation we just saw on the previous slide, number of protons minus charge. If you have a different number of electrons compared to number of protons, that would mean you have an ion, either positive or negative. So with that, let's look at some examples. In example 3, I have 5 different atoms shown, and what I'd like you to do is figure out what the isotope notation would be for each of these 5. Let's do a few examples together. Taking a look at this atom right here, first thing I want to zero in on is how many protons there are. And you can see that protons are there in the middle. There are 7 protons. So if I take a look at my periodic table to determine what element this is going to be the element nitrogen. And the atomic number goes on the bottom. Now don't assume that we're looking at a regular nitrogen atom. I have to look at what information it's giving me. This particular atom here has 7 protons and 7 neutrons. So together, it has a mass number of 14. And then finally, to figure out if this has a charge, I need to count up how many electrons there are. The electrons are indicated by the little dots surrounding the nucleus. Don't pay too much attention to the blue versus the red. I took this image from something else. We just want to look at, okay, all of those dots are electrons. So it looks like I have 2, 4, 6, 8, 10 electrons. And think about that. You have 10 electrons compared to 7 protons. Looks to me like we have 3 extra electrons that don't have a proton to balance it out. So that means that overall, this atom is actually an ion with a -3 charge. I don't know what I just pulled up. Quick note, Some of you may have been noticing that when I write the charge up here, I always write the number first and then the sign, versus some of you might put -3. Technically there is a difference, but to be honest, I'm not going to care too much, and so you can either put 3 negative or -3. Just know that I will always do the number first and then the negative sign. Last thing, I'm actually not asking you to answer this question, but just for some extra practice, is this atom considered an isotope? Well, to answer that question, let's look at what an average nitrogen atom would weigh. So looking at my periodic table, I look and see that nitrogen, the average mass for a nitrogen atom is about 14. And so since that matches, this would not be an isotope as much as it is, that's just a regular atom of nitrogen. Is this an ion? Yes, it is. This is an ion because it has a charge, positive or negative. Specifically, it's an anion, but it's an ion. All right, let's look at a few other examples together. Let's take a look at this one right here. So it's drawn a little differently than the one over here, but we can still solve it. So the screen is showing me that the green dots right here, the green circles, those are going to be my neutrons. So my proton then, because I know that has to be the protons, it's 1 proton. And so I look and I say, okay, the element hydrogen has 1 proton, and I'm going to write that atomic number down at the bottom. What would be the mass number? Well, the mass number is how many protons and neutrons total. So there are 3 particles making up that nucleus, which means it has a mass number of 3. Finally, to figure out if it has a charge, I see it's really, really, really tiny, but I see that there is an electron out here, just 1 electron. That 1 electron is going to be canceled out with that 1 proton, so it ends up actually being neutral. Is this an ion? No, it is not an ion because it doesn't have a charge. Is this an isotope? Well, what does a normal hydrogen atom weigh? If I look at my periodic table, a normal hydrogen atom has a mass of approximately 1. However, this particular hydrogen atom has a mass of 3. So this is an isotope. Specifically, if you remember from the last video, hydrogen that has a mass number of 3 has that special name tritium. I'm not going to necessarily ask you to remember that, but if you ever see tritium out there, you're looking at a worksheet or another website, that's what they're referring to. Tritium is just hydrogen with a mass number of 3. Let's do one more together, and then I'm going to have you do the last 2 on your own. So if I take a look at this one, once again, the neutrons have to be indicated based on, because it doesn't have them specified. So it looks like the lighter colored circles are going to be my neutrons. So in this drawing right here, I see that I have 3 protons. Those are the darker colored circles. So what element has 3 protons? And if I look at my periodic table, that is going to be lithium. So lithium's the element, 3 is the atomic number. Total, remember it's always the total, not just the neutrons, but total, I have a mass number of 8. There are 8 subatomic particles composing this nucleus. Finally, let's look and see if I have an ion on my hands, which means I have to look at my number of electrons. Looks like I have 3 electrons and I have 3 protons, so they're all balanced out. So this is not an ion. Finally, ask myself, is this an isotope? What would lithium's mass normally be? If I look at my periodic table, lithium's mass would normally be 7. So, since this has a mass of 8, this one is an isotope. Alright, go ahead and pause the video now. Try the 2 on the bottom on your own and then see how well you did. Alright, if I take a look at this one on the bottom left, we have, it is magnesium because of 12 protons. Mass number is 26. Because there's 10 electrons compared to 12 protons, that means it has an overall positive 2 charge. This is an ion because it has a charge. It's also an isotope because the regular mass of a magnesium atom would be roughly 24. This particular atom has a mass number of 26. If I pop over to the bottom right, we are looking at an oxygen atom because of the 8 protons. If I add up the protons and neutrons, I get a mass number of 18. The electrons, I have 2 extra electrons than I have protons, meaning that it has an overall negative 2 charge, meaning it is an ion, and also because the mass of an oxygen atom is normally 16 versus 18, that would make this an isotope. Alright, let's do some more practice. In your notes, you should have a table that looks like this, for example, 4. You may be given something like this on the exam where you have some bits of information and you have to fill in the rest based on what's given. Each row is a separate atom or ion that we need to solve for. Let's do one, maybe 2 rows, and then I'll let you do 2 on your own. So taking a look at this first row right here, all I know about this particular substance is that it has 16 protons and it has a charge of -2. What are the other things that I need to find out? I need to figure out what's my number of neutrons and electrons, what's the mass number and atomic number, and then are they considered an ion or isotope? Just say yes or no. And so, since I know the number of protons is 16, I also then know my atomic number is 16, because those are always the same thing. The next thing I'm going to address is the fact that I know this substance has a -2 charge, which means it must have 2 extra electrons than it does protons. If this was neutral, meaning it didn't have a charge, the electrons would be the same as the protons, meaning 16. But because it does have a charge, specifically -2, that must mean it has 2 extra electrons, so 18. Finally, I would want to probably figure out what the number of neutrons is. Well, it doesn't give me a mass number, and I can't figure it out any other way, so I have to look at the periodic table to figure out what element I'm looking at and assume that I'm looking at a typical element of this particular substance. So what element is 16 protons? That's going to be sulfur. And if I take a look at sulfur's average atomic mass on the periodic table, it looks like the mass of a sulfur atom is on average 32.07. I'm going to round that to 32 because remember the mass number always has to be a whole number. So if that's the mass number and the number of protons is 16, 32 minus 16 gives me 16 neutrons as well. Finally, I have to ask myself, is this an ion? Yes, it is. I'm going to put a Y for yes. It is because it has a charge. Is this an isotope? Well, considering we took the mass number from the periodic table, no, it is not an isotope because I'm assuming I'm looking at an average run-of-the-mill sulfur atom. Let's do one more. Let's do the second one. All right. For the second one, we have, actually, let's not do the second one. I'm sorry. Let's do the third one. I'll let you do the second and the fourth one. So looking at the third row, okay, I have 3 pieces of information. I have the mass number is 14, atomic number is 6, charge is -4. So first thing I always try to do if I can, let's solve the number of protons. Since I know what the atomic number is, that's the same thing as the protons. Always the same thing. It does give me the mass number, so I could figure out number of neutrons. 14 minus 6 protons means there are 8 neutrons in this particular atom. And then to figure out the number of electrons, I'm going to go based off of this -4. If this was a charge of 0, my number of protons and my number of electrons would be the same. But since there's an overall -4, that means there must be 4 extra electrons, which means there would be 10 electrons. Is this an ion? Yes, it is, because there's a charge. Is this an isotope? Well, let's check. What element are we looking at? It has 6 protons, so we're looking at carbon. And carbon's average mass is about 12. This particular carbon atom, though, has a mass of 14. So since it's different than the periodic table, that's a funky Y. I don't know why I'm drawing it like that. Yes, it is an isotope. Go ahead and pause the video here, and then I want you to try rows 2 and 4 on your own. All right, let's take a look at row 2. So we've got 20 protons, 20 neutrons, because I had to assume that we were looking at an average atom of the element 20, which would be calcium. +2 charge, that means yes, it is an ion, and no, it's not an isotope because I took the mass number from the periodic table. On the fourth one, based on the information given, I know my atomic number is 13 because that's my number of protons. Number of neutrons is 16 because these two need to add up to be the given mass number here. Because I only have 10 electrons compared to my 13 protons, that means overall it's a +3 charge. Yes, it's an ion, and 29 differs from the periodic table, so yes, it is an isotope. This last slide here is just a little extra practice. It's not in your notes, but I encourage you to do this one. Go ahead and pause the video, and then hit play to reveal the answers. All right, there are the answers for the first 2, protons, neutrons, and electrons. And then for the second question down here, hopefully you noticed that it was 66 neutrons. So you first had to figure out how many protons by subtracting 114 and 66 to get 48. That wraps up this section. We'll see you in section 4.